Guys, welcome once again to my channel. In this tutorial, we are expected to find the value of t in t to the power of t is equals to 33. Our goal is to find the exact value of t that can satisfy this particular equation. Indeed, we are trying to know the number that will raise to itself to give us what? 33. Let's try and make our initial guess. Our initial guess should be that when we raise 1 to the power of 1, it gives us what? 1. And when we raise 2 to the power of itself, 2 raised to the power of 2 is basically 4. And when we raise 3 to the power of itself, is giving us 27. Then if we raise 4 to the power of 4, it is giving us 256. So this shows that at this particular point, you can see that 27 is actually less than 33 and 256 is very well greater than 33. This shows that this value 33 we are looking for is within the value of 3 and what? 4. So we say that the range of values we are looking at, because this is actually less than 33 and this is greater than what? 33. Okay? That means the range of value of t must be within that 3 is less than t and t is less than 4. So these are the range of values of what? T. T greater than 3 and t less than 4. Okay? So this gives us an insight of what t is going to look like. We don't have time to be checking the decimal numbers like 3.1 raised to power 3.1, 3.2 raised to power 3.2, but using this method gives us an insight of how the value of t will look like. So the question really says that t to the power of t is equals to 33. So the first thing we are going to do is to take the natural log of both sides, or the ln of both sides. So if you take the ln t to the power of t is equals to ln 33. Okay? Recall the properties of logarithm that whenever you raise log to the base of log of m raised to power n is equals to n log n. So what do we have here? This t, we have it as t ln t is equals to ln 33. So at this point, we are going to make use of the Lambert W function. The Lambert W function, which is represented as what? W. Okay? So when you have a function which is x times exponential x, that the output is equal to x. If you have a function under Lambert W function that 5 exponential 5, that the output is also equal to 5. I'm just giving you an instance. We need to convert this particular function. We have to put it back into the Lambert function, Lambert W function. So what do? We need to write this to be in terms of this. You remember that first thing we are going to do is to simplify this term. You remember some of the identities we have, that whenever we have e to the power of ln x, that the answer is x. So we can now write it in terms of what? T. So instead of writing t, we can now say that e to the power of ln t should be equal to t, right? So we are going to substitute t to be ln e to the power of ln t, because at this point, e will cancel out the ln. So leaving us with what? X. So if you apply it here, what do we have? We are going to have ln, we are going to have exponential ln t times ln t is equal to ln 33. We are going to apply the Lambert W function, but at this point we need this ln to be the first. So what do? We write ln times exponential ln, and that's equals to ln 33. Okay, so let's apply the Lambert W function. That means a capital W representing it, you have it as ln exponential ln, and this is equal to the W, which is the Lambert function, ln 33. Okay, because the reason why we did this is that multiplication is actually commutative. ln times this is still the same thing as this. Actually, nothing changed. To be ln is equal to the Lambert W function of ln 33. Okay, so all we have to do is actually to get the value of what? T. To get rid of ln, we take the exponent. So we have the e ln t is equal to the e of Lambert W function of ln 33. Okay, so that here you can now see that this e will remove the ln. What do we have? That our t is equal to exponent of the W function of ln 33. Okay, and that's the what? Answer. Video educative. Please do well to like, comment, and share for more exciting math tips like this.